Hey everyone, welcome back. In this lecture, we're going to be talking about how we can take our descriptive statistics and make them a little bit more informative by visualizing. Now we're going to use this paradigm of visualization in R using GGPlot. GGPlot lives within the tidyverse universe, which I kind of alluded to earlier as a set of packages that all are using the same sort of aesthetics and language kind of stylistic choices. So we're plotting because we need intuitive ways to explore the trends in our data and gain your bearing before you're starting statistical analysis, right? So this is a good step while you're conducting your descriptive statistics. It's also an invaluable tool for representing your results to others in papers and presentations. So we're going to be using a library called the Palmer Penguins Library. And I'm going to give you guys some kind of code and framework for creating some of your own visualizations that you'll use in your homework. So let's talk a little bit more about GGPlot. Again, it's based on the Grammar of Graphics, which is a book. And it utilized the idea that you can build every graph from the same components, right? There's a data set, a coordinate system, which we're going to see as our aesthetic layer, and geoms, which are the visual marks that represent the data points or what kind of graph we're going to be building. Again, this is part of the tidyverse. So there's 3 layers: specifying the data, mapping the aesthetics, which is going to be our variables, and then adding the geometric layer, which is what kind of graph we're going to make. So we're using this penguin data. So go ahead and take a moment to pause and write all this down. So you're going to need to install and load the libraries for the tidyverse and the penguins data set. So pause now. Once you've done that, you can glimpse. This is another function and kind of see what's happening in the penguin data set. We see we have 344 rows, 8 columns of variables. Those variables are species, island, bill length, bill depth, flipper length, body mass, sex, and years. We see we have a combination of interval ratio, nominal, and ordinal. And we can play with these with GGPlot. So the first layer, go ahead and pause and write this. The first layer is specifying the GGPlot function and isolating our data. So our data is going to equal penguins. We then need to add an aesthetic layer. Go ahead and pause here. In this case, we're adding an x-axis, which is going to be one of our nominal variables. So this is going to be a visualization that we can make if we have a nominal. We're then going to add our geometric layer. Pause here. Our geometric layer is what kind of plot we're going to make. So we're going to make a bar plot in this case. Our bar plot is one of your best visualization tools for counting the frequency or the amount of times that each of your categories occurs. So the geometric layer falls outside of the aesthetic layer parentheses. So when you're writing this down, make sure you've got the closed parentheses here, right? So surrounding data and aesthetics. So the aesthetic layer, where we're going to isolate our species as the X layer, we're going to close all this parentheses, add a plus sign. I recommend tabbing down, entering down into the next line, and then specifying geom bar. So in tidyverse, it's always going to say geom underscore something. And in this case, we're specifying bar. So when you run that code, you'll get something beautiful like this. So in this case, we can see that the Adelaide species has almost 150 of those penguins. Chin straps, there's maybe like 60 or 70. And then Gen 2, we're in the world of maybe like 125. So we can see how many of each kind of penguins we have in this data set. Very cool. So super simple. The code is going to look a little crazy to start, but once you kind of start thinking about each different layer, it'll get a lot more clear. So if you need another chance to pause here, write this down, run the code, get your picture. So again, to reiterate the plain English explanation, we're creating a GGPlot using the penguins data frame. That's our first layer. We're mapping the species onto the x-axis, and then we're adding the layer of the bar plot. So what's an example of how we would do something like that if we just had, instead of a single categorical or nominal, what would we do if we had a single continuous? A good example of that kind of plot you can use is a histogram. So when you have a histogram, you're doing very similar things, but that X layer, that aesthetic layer, is going to be a interval ratio variable instead of a categorical. So data is still equal to penguins. The aesthetic layer, instead of equal species, it's equal flipper length. And then instead of adding geom bar, we're adding geom histogram. This gives us a visualization still of counts, but it allows us to look at the frequency of those counts within flipper length. And so we actually get an understanding of how many are happening across that continuum, right? So it's better for interval ratio. So histograms are one of the best options you have there. This is another chance to pause and write. So because we're working in the tidyverse, we have the option to use pipes. Now, pipes make things a lot easier on the eyes and computationally faster. So I'm going to give you an example of how to include a pipe in your language. So pipes essentially let you port the data, in this case, without having to specify the data equals penguins. It allows you to pipe it in proactively, basically. So this technically is our first layer. We're piping in penguins into the GGPlot function, and then the rest of this stuff stays the same. So option to pause here and type. And you can type the pipe function. Obviously, it's percent and then a greater than sign and percent. You can also do Command Shift M. And Command is the Mac version, but Command Shift M will also immediately just give you a pipe. Okay, so we're going to be using pipes from this moment on because it looks a little bit easier on the eyes, and it's a fun trick for when you get on later. It also helps you from embedding too many functions within themselves. It makes things a little bit more simple in that way. So that's not only makes things more efficient and easier on the eyes, it keeps you from having to embed tons of functions inside themselves. So say we wanted to add both color on here as well. So in this case, we want to not just have the species show up as different lines on our x-axis. We also want to add different colors for each. So in this case, in our aesthetic layer, we're adding an argument called fill, and fill, when you set it equal to species, will essentially give you a color and a legend. And so option to pause here right now. Once you've got that, I want you guys to keep in mind that all of this stuff stays the same essentially. So this is the same pipe function that we had in the last one. All you're doing is just changing what you filled in the aesthetic layer and the geom bar. So what I recommend you doing is copy and pasting, right? So that makes things so much easier instead of handwriting every time. So copy and paste the framework that you had from the last one using the pipe, switch the aesthetic function, add fill, and change to geom bar instead of geom hist. You can find all of the colors at this link. So I'll probably give you guys either a blank version of the slides or this will be featured in your module. So say we wanted to add an additional variable. So we'd only been working on single variables earlier. Say I wanted to add a variable. So we're doing both categorical and nominal. And then we're adding the island variable on top of it. So we have two categorical nominals, and we want to see how those different species of penguins maybe are distributed over different islands. So instead of filling by species again, we can then fill by a different variable so we can visualize those two different variables at once. So copy and paste the code from the last one. And instead of having fill equal to species, I want you to set fill equal to island. Pause here. Once you set fill equal to island and you run the code, you can see that Gen2s are almost exclusively on Bisco. Chin straps are only on Dream Island, but the Adelaides are actually kind of equally distributed across the three islands, which is an interesting finding. And so this is where we could see maybe some of the mode on its own wouldn't be all that helpful, but once you visualize that mode across the different islands, you can actually kind of start to see patterns on where these penguins live. Another way to visualize this is with a standardized bar chart, right? So we're all still in the world of bar charts, and we're looking at multiple different categorical or nominal variables. We can see what percentage is existing in each island. So everything stays the same. And we're just adding this Y lab. So you have to add a plus sign, adding a Y lab argument. And we're also adding inside the geom bar function, the position equals fill, excuse me. And that will give us a standardized bar chart. So these are the two new components. Y lab equals percent. So it knows to make a percentage on the Y lab, and then within the geom bar, if the position equals fill, it's going to fill it all the way into a standardized bar chart. And so we can see that about 30-ish, 30% of the Adelaide species is distributed across the islands, whereas the chinstrap and the gentoo are 100% of them exist on these other islands. So pause here, add the additional components. Okay, so say we had two variables that were not the same kind. We have continuous and categorical this time, which means we have interval ratio and nominal. So say we wanted to look at species and look at bill length. There are two different options here. You could use a violin plot or a box plot. We're going to try both, but I think we're going to just look at the violin here first. So we're going to pipe in the penguins data set into our GGPlot function. The aesthetic layer, our X is going to be species, same. Our Y is now going to be bill length, okay? This also allows me to add different layers. So this actually is a box plot that's embedded in a geom violin. Both of them show density, right? So if you add the geom violin with an aesthetic layer, then it also filters and makes the different colors kind of pop for the different species. And then we're adding a box plot inside of that with a width that fits inside of that. And the fill is same, equal to species. And so the violin plot, you can do one or the other of these. You don't need to do both. So you could stop here at geom violin and get rid of all of this and it would still work. Or you could do the opposite. So in this case, the violin gives us a better understanding of density through those curved lines. And then the box gives you the density based on where that little mean value is, right? And so you can see that the mean falls somewhere closer to 50, and that's where the peak in these densities are in the violin plot. Same thing for the Gentoo in the blue. This is closer to like 47, 48, and it's also kind of near where this kind of bulk of the density is here. You can see that the Adelaides have a nice smooth curve, and so their mean falls right in the middle of that kind of smooth bell on either side. So histogram or violins and box plots are great for interval ratio and our nominal variables. So say we have two interval ratio variables, two continuous. So in this case, we might have something like bill length and bill depth. We can do the same sort of thing we've been doing, but switch to using geom point. So your aesthetic layer will be bill depth as the X. The Y will be bill depth or bill length. And then instead of doing something like geom hist or geom violin or geom box plot, we're using geom point to make a scatter plot. And we don't have any color layers here, obviously. And so moment to pause and allow you to go through this. So once you have this, you have this kind of somewhat informative scatter plot that kind of shows more of an amorphous cloud. It really doesn't look super helpful at this point. There might be a slight positive association between bill depth and bill length. So as bill depth gets bigger, bill length gets bigger. But it doesn't seem super clear. So what happens if we wanted to maybe add a third variable to the mix that'll make things make more sense? Let's add some color. So in the aesthetic layer, we're going to color based on species instead of fill. And then we're going to add that to the same thing we've already had. So this isn't using a pipe. This is going back and using the penguins as the first argument. You can go ahead and put penguins as a pipe, though. It'll work the same. And pause to go ahead and do that. Once you have that, you see that the relationship between bill depth and bill length is based on species. So the blue is clustered around itself, the green's clustered, the red's clustered, and this is because the relationship and the size of bill length and depth is based on species. It makes a lot of sense, but it took adding that color layer to actually see what was happening. So think about the fact that we can use not only 2, but 3 variables, and sometimes that actually elucidates the pattern much better than just looking at 2. So the other thing you can do is add shape. So I'll give you a second to pause here. Once you add shape, you can see that we've got squares and triangles and circles, and this can be helpful, especially if you have to publish or do something in grayscale. You won't be able to show the colors, but you could show shapes instead to show the same pattern. So I'm going to give you also this as a resource. It gives you kind of starting ggplot code. So if you install the Mosaic and load the Mosaic library, it allows you to kind of give like a point and click interface to different kinds of variables and plots. And it also kind of returns the ggplot code that you use. So I'll let you guys have access to this, but I prefer you to kind of work on playing with the actual code itself. And then also there's a ggplot cheat sheet that I'll link as well, that gives you access to a bunch of shorthand and key terms for ggplot. So I feel very confident in your guys' ability to learn ggplot code, but I understand it can be a little bit overwhelming at first, but hopefully you've got enough resources to kind of start moving forward with playing with ggplot.